Welcome to the Real Python podcast. This is episode 11. Have you wanted to get started with testing in Python? Maybe you feel a little nervous about diving in deeper than just confirming that your code runs. What are the tools needed? And what would be the next steps to level up your Python testing? This week on the show, we have Anthony Shaw to discuss his article on the subject. Anthony is a member of the Real Python team and has written several articles for the site. We discuss getting started with the built-in Python features for testing and the advantages of a tool like PyTest. Anthony talks about his plugins for PyTest, and we touch on the next level of testing involving continuous integration. Anthony recently finished a talk for PyCon 2020 online, titled, Why is Python Slow? He had the idea for the talk while he was working on his upcoming book about the CPython source code. I also want to give you an update on last week's episode with Kyle Stratus, where we discussed Kyle being let go from his job due to the pandemic. Well, here's some good news. Kyle will be joining a Boston startup called Visit as a senior data engineer. Congratulations, Kyle. All right, let's get started. My name is Christopher Bailey, your host. The Real Python podcast is a weekly conversation about using Python in the real world, interviews with experts in the community, and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Welcome, Anthony.
Hi, Chris. Great to be on the podcast.
Yeah, thanks for joining me. I was just looking on Twitter and noticing that you were just wrapping up the details with your PyCon 2020 online talk.
Yeah, I finally managed to get it finished. So now that PyCon is virtual, I mean, obviously we're not meeting face to face this year with everything going on. So that basically PyCon is virtual, and everyone who'd been accepted to give a talk, they asked them to record their talk anyway, if they were comfortable to do so. And then you submit it online, then it goes onto the YouTube channel. So yeah, I've just finished putting mine together.
Have you done many of those recordings like that?
I've done them for, so I've done a couple of Pluralsight courses.
Okay.
So I'm used to like pre-scripted recording, but doing what was basically like supposed to be like a live presentation and recording and doing slides all at the same time was really too much for my brain to handle when I tried it. So I ended up really writing down what I was going to say. I found that if I just tried to, ad-lib it, then I just went off the rails. So yeah, I cheated a little bit, but I think I wasn't the only one to do that. No,
I bet not. It's hard, even just me, getting into the podcasting thing, just like, okay, how am I going to roll into these questions and remember what I'm going to talk about, and kind of challenging to the creativity in a lot of ways.
Yeah, if you're on stage, I think it's a bit different because you've kind of got this adrenaline kicking in, and if you make a mistake, you just keep going. Whereas like when you're recording, if you make a mistake, you can just stop and start again. But that's actually a negative because it just means that every time you make a mistake, you kick yourself and then you stop and restart and it throws you off.
Yeah.
So it's actually quite challenging to do the whole thing end to end.
Yeah, totally. What's your talk about?
The title of the talk is Why is Python Slow? And it's a pretty technical talk. It's really kind of looking into comparing Python's CPython specifically, and the performance of CPython with certain benchmarks against other runtimes. In particular, I call out Node.js because I think it's quite similar. JavaScript's quite a similar language to Python.
Sure.
Not in terms of syntax, but in terms of like it's dynamically typed and interpreted.
Cool. You've been spending a lot of time in the C side of Python lately with your book that you're working on, and I think I maybe saw a post that you have just finished it. Is that right?
Yeah, I've just finished the book. So the book is called CPython Internals, and it's a deep dive into the Python 3 interpreter. So the actual application that runs, understands, and executes all your Python code. It's been a year. I think it's taken me to put the book together. So I'm really excited to have finished it.
Oh, wow.
And the talk kind of came off the back of that, actually, because I kind of discovered a few things while putting the book together related to perceptions about performance and realities about performance in Python. And I thought I could kind of summarize those in 25 minutes and share it in a PyCon talk.
That's cool.
But the book is a lot more detailed.
Oh, I bet. Yeah. Who's the intended audience for that book?
That's a really good question. It's very curious people.
Yeah, sure.
So I guess that's one of the audiences. So people who have like a real passion for software engineering and like to understand how things work. So if you've been working with Python for a long time, there's kind of a curiosity, like how does this thing actually work under the hood?
Yeah.
But I appreciate that that's probably not a massive audience. You know, a lot of people are happy to just use it and they don't care so much about how it works, or they don't have the time to dig into the details. So it's also got a lot of stuff in there for intermediate and advanced developers, teaching you about memory management, parallelism, and concurrency techniques you can use,
Cool.
debugging, load profiling, benchmarking, a whole bunch of advanced techniques that the CPython project uses. And there's actually ways that you can reuse those in your own code as well.
I was thinking about, after talking to a couple people in sort of the embedded systems, Arduino, CircuitPython group and stuff, how maybe understanding a little more of what's going on with C would help those kinds of projects, since a lot of it's, trying to deal with the hardware directly, especially with something with like audio. I don't know if the book would get into those kinds of things.
Yeah, it talks about a lot about how C manages memory and how it manages processes and stuff like that, which you do need to understand if you ever work with C extensions. So Python's great because you can just stick with pure Python.
Right.
But sometimes if you need to interface with something like a piece of hardware, or then you need to, use drivers to do that, and you need to actually use libraries which have been compiled. And in those cases, then you have to write something called a C extension, which is basically a C program, but it has like a little wrapper on top of it that says, if you want to call this from Python, this is what the function would be, this is what the arguments are. And then you can just import it into Python and run it directly. So if you ever need to write a C extension, it would definitely help you with that.
That's cool. Thinking about the PyCon 2020 being virtual now, I was wondering, how many conferences do you typically attend in a year? This year's going to be very different, right?
Yeah, this year's going to be 0 probably.
Yeah.
I'm not one of those people who spends the whole year on the conference circuit. First of all, I'm based in Australia, so a lot of the big tech conferences are in the US or in Europe.
Yeah.
And they're so far to get there. There's a couple in Australia. There is a PyCon in Australia, PyCon AU, which is going to be virtual as well this year. So I normally do maybe 3 conferences a year, PyCon being one of the big ones.
Yeah, it's such a bummer. I was so excited to hang out with the Real Python team.
Yeah, it was fun last year. We had Dan set up a space for us, and we had some time together during the conference where we could hang out and catch up. And it was the first time most of us who work on Real Python had actually met face to face before. So it was really cool to get to know everyone better.
Yeah. How long have you been writing for Real Python?
A year and a half. I've only done 3 articles.
Okay.
But as I'm sure you've kind of discovered, each article takes a lot of time.
Sure does.
It's quite a big time investment. And the first one I did was the testing article, and then I did one on refactoring, and then one on the CPython source code. The source code one is a massive article. It took me quite a long time.
That's what kind of led to the book, right?
Yeah, it was. It was like it was a suggestion from a reader on the Slack channel. They said that it would be really interesting to understand like how to navigate the actual source code for CPython.
Okay.
So that's how it started, and then it kind of spiraled into a book, I guess. I'm not really sure how that happened, but
yeah. So we were going to talk about the testing article today.
Yeah.
I guess to start off with, my background on testing is very minimal. I was working in a marketing department in a bank, and we were doing a lot of Jupyter stuff, doing a lot of other sort of scripting elements, and an occasional like Flask or very minimal Django type of app. And so that's about as much testing as I did, is like the kind of making sure things work properly inside of like a Django app. But I wonder, kind of as a background, what types of projects should somebody be looking at moving toward testing?
So the goal with the article actually was talking about like getting started with testing in Python. It wasn't here's all the best ways to do testing, or like here's all the advanced testing techniques.
So it's not necessarily like a best practices kind of thing.
Yeah, I mean, I do kind of cover off some of that stuff, but I want to start from the absolute basics because
Okay.
often when I talk to people about testing, either newer developers or people who've kind of been developing for a while, they, whenever you bring up the topic of testing, they immediately start sort of being almost apologetic, or they're like, oh, well, we haven't got around to testing yet, or I don't really do much testing. And they kind of start almost like, it's like almost like a point of embarrassment or a point of apology. And what I wanted to get through on the article was, first of all, like, everybody does testing already. Like, you don't just make a change to an application and then just like send it off on its way and you just assume that it's going to work.
Yeah,
like,
hopefully.
Everyone does some form of testing. Hopefully not, anyway.
Make sure at least works for me, right?
Yeah, you could at least run it once locally to see if it did the thing that you thought it was going to do. Especially with Python, because you don't have a compiler to tell you that you've made some horrendous mistake with properties or types or something. So everyone does some level of testing already. It's just normally manual testing or just like basic like smoke testing. Like, if I kick it, does it start?
Right.
Does smoke come out the sides, basically?
Right.
That's my version of smoke testing. So the goal of the article was to go, okay, so you've like got an application you've been working on typically, and you want to add tests to it. Like, what is the simplest way to do that? I don't want to go, here's all the test frameworks you need to learn. Here's the stuff you need to study. Like, here's the difference between, I don't know, this type of test style and that type of test style. It's like really basic. You have an application. What is the simplest way you can see if bits of it work? And a good way to start is actually to think about the bits of the application that you're most worried about, or you like as a developer. I think when you work on an application, you really get a feel for like the bits of the code that are a bit more fragile than others. Like, they need a bit of extra special care. And those are the ones that normally cause bugs, and whether those are like logic bugs in the code or like stability issues or where you get crashes and stuff like that. So yeah, the idea I think is just to think, okay, with those parts of my app, can I put some stuff in place, which is normally just simple functions to import the module, run the function, and just check that it does what it's supposed to do. And you can start with the most basic thing.
So in that sort of situation, would you suggest that someone starts with like just the built-in like unit test?
Yeah, in the article, I recommended people to start with Unittest. I mean, I'm a big fan of PyTest as an alternative to Unittest, but if you're just starting out, then I don't want people to have to go and learn a whole new thing if they're going from like nothing to their first test.
Right.
So I think once you've used Unittest and you've written some tests using the Unittest. I should clarify.
Sure.
Unittest is a module in the standard library. It is also confusingly the name of a testing technique.
Oh, okay. Sure.
But if you import Unittest in Python, it's a module built into Python, and it has like a test. It's got a class called test suite, and you can add functions in it called test something. And if you run that module, it will basically like run the stuff inside the function. And you put assertions in it to say, assert that this value equals this value, and then it will pass or fail the test. So I do recommend that people start with Unittest because it's built into Python. There's nothing else you need, and it's pretty simple to get going and get started with.
Yes, that assert statement is like the really common statement that you see kind of throughout that, where you're just agreeing that this is what it should be, right?
Yeah, so there's kind of like an idea in testing with arrange, act, and assert, like as a pattern. So arrange means like, construct your like input data or set up the thing you want to test. Act means do the thing, and then assert means verify that the output. So like if you were going to test, I don't know, like a coffee machine,
sure,
then your arrange would be like put coffee beans in and some hot water. Your act would be turn on the coffee machine and press make me a coffee, and assert would be drink the coffee. Does it taste like coffee?
How'd it turn out?
Like those are kind of like your three steps.
Right.
Yeah, those are kind of like your three steps. And the assert bit is probably the bit I think that people struggle with at the beginning, because it's like, okay, how do you assert, okay, coffee example, I don't know if it's great, but like, how do you assert that it is coffee? Like, is it brown? Is it hot? Does it taste like coffee? But in the Python space, you've kind of got assert that the one of the outputs looks like this. And one of the big challenges people have when they're writing tests for the first time is that they have these kind of like mega functions or mega classes that do like 1,000 things. And they don't necessarily have like a really obvious output that you can assert against.
That you can't like apply like a true false kind of capability out of it.
Yeah, it's not. Yeah, and all the examples you get on testing tutorials are like, oh, let's see. Actually, I think I probably even use it in my tutorial, but like, let's test a function that calculates two numbers. And it's like, okay, well, that's easy because you can assert that the output with the fixed input is correct.
Right.
But in the real world, like functions and classes that you're testing can do many things.
Yeah.
So I guess one of the next steps is actually to think about how your application is structured so that you follow the single responsibility principle, which means that a function should do one thing, and if it does one thing, then it's a lot easier to test because you're acting on an input and you're testing the output. So once you use testing more and you kind of follow some of those design principles, like when you build your code, it does become a lot easier to test. But if you try and stick tests in at the end when you've already made the application, it's a lot harder to do.
I can imagine that you've created all this code and you have really just a very simple or maybe even a complex kind of like idea of like, this is what should come out of this thing. Versus if you start with testing in mind, then you're able to kind of think about all the steps that are going to go into the testing as it's being built, or all the spots that you would put it in. Whereas I think maybe you would think with like a big function or big script or whatever, you might be just looking at, I'll just put one big test at the end, that will plan for this thing, where it might be harder to diagnose what failed.
Yeah, definitely.
So when you move beyond simple tests in something like the built-in Unittest library and you move into something like PyTest, what is it adding?
I think the biggest benefit of PyTest is the plugins.
Okay.
So the PyTest tests are a bit, so actually you can, if you've written tests in Unittest, then you have a test module. So your Python file, inside that you have a test class, a test suite class. And then inside the class, you have test methods. And you can just run that in PyTest. So PyTest understands unit test syntax and it understands like unit test patterns. So if you just move to PyTest, then you can just use your existing test code.
Nice.
PyTest has its own style, which is that it doesn't use test class. Well, you can use test classes, but actually it kind of prefers more functional style. So you have a test module. So you're like your Python file, and inside it you just declare lots of functions called test underscore something, and you just test things. So that the way that you do that is a bit different. Also, PyTest uses the assert statement. So you would actually just write it in normal fluent Python. Whereas in Unittest, when you use the test suite class, there are some internal methods called assert, like assert equals or assert in or assert none or something. So rather than using these kind of funky methods like you do in Unittest, you just write an assert statement in fluent Python in PyTest. So it's actually a bit easier, I find, to write the assert part of the code in PyTest. But PyTest has like a massive like plugin ecosystem. So, you'd mentioned Django before. So like the PyTest Django plugin is fantastic. I know that Django projects, like when you set up the initial template, it comes with like the Unittest test runner. But the PyTest Django extension is really nice. Like it shows you how to create test databases, how to run view methods, how to check routes, how to, like all the kind of things that you would actually need to do in a Django application. It builds all that infrastructure for you. And all you have to worry about is, okay, I've got a client object and I can just run get on the client object and give it a route, and it will just give me the response back from the view.
That's nice. All that infrastructure is part of what you're getting with PyTest. You're getting lots of plugins for, like a lot of different other platforms too, beyond Django.
Yeah, absolutely. So there's plugins for, they don't all come with PyTest. You have to kind of install them on top, but there is a like a plugin website, I guess, where you can find them, or you can find them on GitHub. So yeah, there's plugins for like all the web frameworks that you would expect, as well as a lot of data science tools.
Nice.
And people have also written plugins for particular types of testing problems, like working with multi-dimensional arrays, for example. I mean, there's so many, I can't possibly like list them on the show.
Sure.
But like,
that makes sense.
Yeah, what you'll probably find with PyTest is that someone's already solved the problem that you're trying to solve and has written a plugin for it, and you can just download and install it and use it, and it just saves you so much time.
So there's a lot of good community resources there. You just need to kind of seek them out a little bit.
Absolutely, yeah.
Oh, that's great.
Yeah.
So is that the tool that you typically use?
Yeah, I use PyTest for all of my own projects, and have also got a couple of my own PyTest extensions, which I've kind of made for problems that I was trying to solve.
What are your PyTest plugins? What do they do?
So the one I kind of is most popular is a plugin for Microsoft Azure Pipelines, which is a sort of DevOps testing, continuous integration, continuous deployment platform. It's kind of similar to GitHub Actions, if anyone's used GitHub Actions. Yeah. But it's kind of built for like bigger scale applications. And it also has like a test manager interface. So basically my plugin, you just stick it on, you just run it, and any test that you run in PyTest will integrate automatically into the test suite UI.
Nice.
And it does coverage data as well.
So what do you mean by that as far as coverage data?
So okay, when you're writing tests for your application, sometimes it's useful to know which parts of the code your tests have hit and which parts it hasn't. So especially when you get to like either quite a modular application or an application that has like tons of submodules or tons of basically like Python files.
Yeah.
So I've worked with projects that have like hundreds of thousands of Python files in them. They've got thousands of unit tests, and you're like, okay, so which bits of the app haven't actually got tests against them? Because those are probably ones that we have bugs in, but we just haven't found them yet. So coverage basically like runs all the tests, and it tells you in a report, this line of code in this file was tested, like a test went through that line of code and executed it, and it will tell you the parts that weren't actually hit at all.
Okay.
So you use it for a couple of things. One is to identify parts of the application that haven't been tested at all. And the other thing you use it for is actually finding parts of the application that haven't been tested because they can never actually execute. So sometimes you've kind of got bits of the code that are either like legacy, got refactored at some point, and they're like what we call unreachable code. So there's actually no path to get to that code in the first place. So, coverage tools can help you find bits that you can take out.
Does it like give you like a percentage, or does it actually highlight the actual areas of code and the parts of your module that are missing it?
Yeah, it gives you both.
Okay, cool.
Yeah, it gives you both. It gives you a percentage, like an overall percentage, which, like, I don't know how useful that is.
Right, sure.
I do put like the test coverage percentage on open source projects that I work on, mostly because it kind of shows that this project has got tests. Because I think if people raise bugs against it or they want to get involved in the project, there's kind of a fear that if you want to get involved in an open source project, that you're going to break something by making a change.
Oh.
So if you already have tests out there, it kind of covers you against this regression scenario. So like if someone submits a change to one of my projects and changes a piece of code, then because I've already got tests against the thing that they've changed, then my tests are going to tell me and the person contributing whether the change that they made broke the tests and either likely changed a behavior that some other part of the application is expecting, or introduced a bug, or sometimes the test was wrong.
Sure.
But yeah, a lot of the time it kind of shows, oh, you changed this thing, but it actually introduced a bug in a different area.
Yeah, it's going to give a really specific way to point out what happened, as opposed to a bunch of text messages back and forth.
Yeah.
In the confusion. That's good. PyTest can move on to even more advanced things like being able to automate.
How do you mean?
As far as like doing automating of your tests, is that something that you can do inside PyTest, or does that require additional tools?
Also, like creating tests automatically?
No, I mean, I guess a tool to help you run the tests.
Okay, yeah. So those are that kind of problem. I guess it's called a test runner, and Unittest and PyTest both have built-in test runners.
Okay.
Once you write the tests, your tests are basically their modules. So they're just Python files with classes and functions, or just functions in the PyTest example. When you run PyTest, it basically creates an application that discovers tests. So like the first stage is discovery. So you normally give it a path, like all my tests are in the folder called test, for example, and it will just go and look in that folder, find all the files that contain tests, find all the test functions within those files, and then queue them up and run them in sequence. So PyTest does that for you. You don't need to give it like an index or something. It will do test discovery. Unittest does this as well. Like it's not unique to PyTest, but it will do test discovery for you. So if you're using an IDE or something, like if you're using PyCharm, then it's got built-in Unittest and PyTest support. Visual Studio Code can do that as well. And if you're using just like a plain text editor, then you can run either of those testing tools just on the console. So you could just run them on the console. So Unittest, you just do Python-m unit test and then the folder that you want where your tests live. And PyTest, you just do PyTest and the folder where your tests live.
Okay.
That's like the simplest way to get started. And it will just go and look in there, find what tests it can, and then run them and tell you whether or not they pass.
Okay. Like another level on top of that would be a tool like Tox that can, I guess it would be like if you're going to share this code and you're concerned about it running on different versions of Python.
Yeah, so Tox, like as a tool, is it solves a couple of different problems. One is, so when you run Unittest or when you run PyTest, it's going to use the version of Python that you called it with. So if you called it from a virtual environment, which you should be, it will use the version of Python that is in your virtual environment. So, if it's 3.7, it will test your code against 3.7. And if your tests use, extra Python modules that you've installed using pip into the virtual environment, if you're using Django, for example, and you've got Django version 2 in there, or like a specific version of Django, and you've got some Django extensions, then it's going to use all those versions. If you wanted to, for example, like upgrade to Django 3,
okay,
then you could go and create a whole new virtual environment. You could go and install all the new dependencies, copy all the code across, and then run the unit tests and see if they pass. But Tox basically gives you a way of automating that. So you pip install Tox, and then you run Tox quick start on the command line, and it will just ask you a couple of questions. And then it creates this configuration file, which you can keep it as simple as you want, which is just saying, I want to run this command, which is normally like PyTest or Python-m unit test. So like run my tests, but Tox will actually create the virtual environments automatically. So it creates like a subfolder called .tox, and it goes and creates any number of virtual environments. It creates the virtual environments, installs the dependencies, runs the tests, gives you the output, and then once it's finished, it tells you whether or not it passed. So
wow,
you can, like in its simplest form, you could just test, does my application work on Python 3.7 and Python 3.8, for example? So you can just create a simple Tox file that says, I want a 3.7 environment and a 3.8 environment. And then when you run Tox, just by typing Tox, it will create one virtual environment for 3.7, one for 3.8. It will run the tests against both, install the dependencies on both, and then tell you whether or not they passed. So it's like a nice way to like check multiple Python versions And then also what you can do, particularly with big frameworks, if you're looking at upgrading to minor releases or major releases of frameworks like Flask or even Pandas, for example, like if you were looking at upgrading to, the newest version of Pandas, then you could create a Tox environment that would test the current version and test the new version. And you can give it as many as you like. You can give it 10 if you want, and it will go and automate all that stuff for you.
That's great. Yeah, because I think of that with Django, like you mentioned, is now moving to version 3. It seems like such a rapid change. Like it seemed like Django was hovering in the ones for so long. And then just in the last like 2 years, it's like, okay, version 2, version 3. I can see that trying to stay on top of those types of things could be very useful.
Definitely, yeah. Especially with extensions, if you're using a lot of Django extensions and you wanted to upgrade to Python, not Python 3, Django 3, you'll probably find that some of those extensions are not compatible yet.
This week, I want to shine a spotlight on a real Python video course. It's about a topic most people think they already know. It's titled the Python print function. Go beyond the basics. And in the course, Christopher Trudeau takes you on a journey beyond the fundamentals and shows off features like string formatting, pretty print, the parameters of sep, end, and flush, creating an animation with print, building more advanced user interfaces in your terminal, character encodings, escape sequences, printing to file streams, and debugging. I think it's a worthy investment of your time to learn a little bit more about a feature you use so often. And like most of the video courses on RealPython, the course is broken up into easily consumable sections, and you get code examples for the techniques shown. Get more out of your print statements. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. Your article kind of gets into this automatic execution of your tests and moving into a little bit of continuous integration. Is that something that you're using in your projects?
Yeah, absolutely. I think all the projects that I use, which are open source, actually all the ones that I have, which are closed source as well, like internal projects to the company I work, have some kind of continuous integration. So I guess the difference is that once you've written the tests and you've run them locally, you want to make sure that anytime the code changes.
Yeah.
So if you're using Git, anytime there's a commit in the code, run the tests against that commit. And then you've kind of got like a difference, but especially like if you're working locally and you've made a whole bunch of changes to your code, you've been working on it for like 4 hours and you've changed something over here, you changed something over there, and you've done like 6 commits in that period, and then you run the tests and 4 tests fail and they have to do with different things that you changed during the day.
Right.
Then you've kind of got to figure out like, oh, okay, what thing did I change and why did it break that test? Because especially like if you don't see that immediate feedback, then it's quite hard to know like consequences to things that you've modified. So the idea with continuous integration and continuous deployment is that you've kind of got a tighter feedback loop. So if you've made so CI basically says, whenever there's a new commit in Git, go and do this stuff. And the stuff can be run tests. Like that's the simplest one you can start off with. So if you're using PyTest or if you're using Unittest or if you're using Tox, like you could say, whenever there's a commit, go and run my tests against my application.
Nice.
And there's a whole bunch of services that you can use online to do that for you that would sync to your Git repositories. Even if you're using, like, it doesn't have to be open source. If you're using like an internal Git repository or a private one, there's a whole bunch of tools that you can use to like continually run your test against every commit. And then it will tell you this failed because, and here's the output from the test suite.
Yeah, I think about that idea of like doing the multiple commits and then running tests after it. Coming from a little more of the creative world of like doing video editing or doing like music creation and so forth, the idea of like your undo history is only so useful. It's sort of like a time travel.
Yeah.
It's like, okay, how far back do I want to go? With the changes that I've made, what am I going to lose in that process? This is kind of a nice addition to that that isn't available in a lot of the tools that I've been using for years, like Final Cut Pro or Logic or something.
Yeah, I think especially if you've been working on a software project as like the only or the main developer, then you can kind of get into a habit of, commit my changes for the day. So it's like,
Yeah, right.
here's all the stuff I've been doing today, and I'll commit it at the end of the day and push it. But that's like where you end up breaking multiple things over the space of a day, and you're not really. It just makes it harder for you to then figure out what did I change and why did it break that thing. Whereas like a much better habit is to do a commit per change. So if you've modified this thing over here, like that file or that function or that view or whatever,
Yeah.
then do a commit after that. Like it doesn't hurt. There's no cost of having extra commits. And then when it comes to CI/CD, then it gives you that tight loop feedback.
When it runs those tests on that code, it's still stuff that's popping up in your console locally, or how is that presented to you? I guess it depends on your configuration.
Yeah, CI/CD you normally run in somewhere as like an online service. So because if you've got a Git repository and there's multiple people working on that Git repository, if you had to run the CI on someone's machine, it assumes that they're awake and online. Like it's better to have that as an online service. So you can basically set up like triggers in your Git repository, which the CI services will configure for you. You don't have to figure out how to do this stuff.
Nice.
So if you use GitHub Actions, for example, like you just go in the GitHub project, click on Actions, and you click on a template, and then press save. There's even a template actually for like test my Python project in GitHub Actions. So that's like one of the easiest ones to get started with. Is
Oh, cool.
if you've got a private GitHub repo or a public one, just go to Actions and go to create new, and then it will just say whenever anyone pushes to the master branch, then like run like install Python versions, and you can tell it what versions you want to use, and then like run my tests. So you don't have to figure out how to do that stuff. It configures most of it for you, and all the other CI services are pretty similar. Like they'll hook into your Git for you. So if you're using GitLab or Bitbucket or something, then it will do that for you.
Nice. This is kind of off the main subject here, but what do you think of the recent changes with GitHub? Microsoft purchasing them for one, them making a lot of the functionality free for like smaller teams and stuff like that.
Yeah, I think Microsoft acquiring them was a great move, and they've added a lot of capabilities to GitHub already. If you're using GitHub for open source, it's a great platform, and I've absolutely got no complaints. They've added a lot of new capabilities over the last years. Actions being the CI/CD service called Actions is one of the best. Also, I guess like for teams,
Yeah.
making some of that stuff either free or cheaper has been a real benefit, because it can get pretty expensive using GitHub private repositories for teams of like 50 developers and above. Yeah, so that's a great move to have some of that stuff become either free or just cheaper.
Yeah, I'm kind of excited by that. I was intrigued that the PSF is looking at using GitHub even more.
Yeah, for issues.
Yeah, the issues.
Yeah, so when the PSF moved the Python source code to GitHub a couple of years ago, so it used to be in Mercurial, and it wasn't even on Git. It was on like a different versioning control system called Mercurial, and it was on separate servers. It's just harder for people to like do their first contribution. So it works fine for like the Python core development team, because they've just got their workflow set up, and it doesn't really make much difference. But if you want to actually because Python is open source, so anyone can go and contribute a piece of code or a change or an improvement to Python. Like all you need to do is go onto GitHub/Python/CPython, create a fork, understand the thing that you want to improve or fix, and then you can make a change and send it back, and someone will review it for you. So now it's a lot easier for people to get involved.
Nice.
Because they've moved it to GitHub as more contributions from outsiders. Also, the next idea is to move the bug report, so the issue log, which is currently on a site called bugs.python.org. I don't know what software it runs. I think it's proprietary to the Python team, but it's not super user friendly for beginners, and it's quite hard to find things, and it's quite hard to find like issues that people have raised and that have just been abandoned. Like there's a whole bunch of issues with it, and basically sort of there's a massive pile of reported either reported bugs or reported requests that never get responded to. I mean, I don't know if the software is entirely to blame for that, but the idea is to move that to GitHub issues because it's a sort of more modern tool, and you can do tagging and you can have bots, and they can start to automate a lot of the admin tasks.
Nice.
Because there's like hundreds of thousands of tickets in the bug system, and somebody like manually doing that is just going to be impossible.
Yeah.
So yeah, the idea is to have like bots go and tidy all that stuff up.
Yeah, and since some of the other infrastructure is already there, that's kind of nice. And like I said, they don't have to be developing a separate tool.
Yeah, I think one of the only fears is that people will use it for saying, "Why doesn't my Python code work?"
Oh yeah, I guess that could happen. Yeah,
but they can do that now. But it's not as obvious where to find it.
Yeah. Some of the other areas that you get into in your article is you talk a little bit about this concept of dry, of don't repeat yourself.
Yeah. So the idea with the dry principle is that you literally don't repeat yourself. Python has lots of different ways to make your code a bit more functional. So you can split things up into functions. You can extract pieces of code. It also follows the single responsibility principle. So when you're testing, if you haven't followed these principles, it'll actually make your testing harder. And that's kind of like a side effect. And it also is a bit of what I call like a code smell, which means that later down the line, if you want to refactor your code to have a new feature or like extend something or improve performance or something like that, like all these principles become a lot more important further down the line. So don't repeat yourself idea is quite simple, which is that, don't have two classes or two parts of code which have more or less like the same block of code over. So don't copy and paste code between segments.
Sure, yeah.
I mean, you can take this to an extreme, like you can have pretty much like a function for everything, but like there is definitely a middle ground, which is, try and remove things. When you're writing tests, the don't repeat yourself thing definitely comes into play. You will probably find yourself actually repeating yourself in tests, like the arrange, act, assert thing. You'll probably copy and paste tests quite a lot. But if you're using PyTest in particular, there are some techniques you can use to basically like give it a range of inputs and run a test for each one of those. So rather than copying and pasting the test, you can actually say, run this test function with this array of inputs, and it turns each one into a parameter. So that's called parameterization. And actually, in this year's PyCon, Brian Ocken did a talk on parameterization with PyTest, which is really worth a watch if you're interested.
Yeah, I just saw that one went up. Yeah, he also wrote a pretty popular book on testing, his PyTest book.
Yeah, absolutely. I recommend the book. Yeah, I've recommended the book. I've got it right next to me, actually. I was using it yesterday.
Cool. Yeah, and his podcast kind of focuses on testing and testing code, though just like our podcast will go on a variety of topics too. So
yeah, definitely. It's more for like test. I think there's a lot of test professionals. So people who are like full-time testers, and there's a lot of advanced testing topics on there as well. So yeah, it's good to listen to.
Yeah, cool. Just wanted to get your thoughts on code formatting. What are your feelings on that as far as using tools for solidifying your code formatting?
Yeah, there's a couple of reasons, I guess, to use a formatter. I'm not particular like wedded to a style or layout, other than I say that, but then when I read code that's not in the style that I'm used to, it kind of makes me flinch because it just looks wrong. But that's mostly to do with people who've written code in other languages and then started writing Python and are not aware of the things that you do. So, for example, some other languages you would like variable names is a classic one. So, like Java and C#, for example, kind of have a unwritten rule about like variable names are like camel case and method names start with an uppercase letter, and they've kind of got like a whole bunch of stuff that's their like styles of that language. And then if you just start writing Python, you can do those things. Like you can write functions with uppercase letters, and you can use camel case, but you really, like most Python code in the wild, is in snake case and lowercase method names, lowercase parameters names, and like your variables and stuff like that would normally be in the same style. Classes, for example, would be another one. Python classes are normally capital letter, so it's like uppercase starting, and using camel case. So there's just a whole bunch of stuff like that, which if you've been working with Python for a while, you just know, but they're like unwritten rules. So linters are like a good way of checking that the code follows that style in things like naming and layout and stuff like that. I also find that linters are really helpful for identifying imports which are not actually being used.
Yeah.
Which is a massive one. Like I go and look at code bases, and like half the import statements at the top are never actually used in that module. So
oh my gosh, yeah.
So you can just remove them.
That's a lot of wasted bandwidth there.
Yeah, it is. So imports in Python are expensive in terms of like memory and CPU. So like those tools can be really helpful to just scan your code and go, hey, you could remove 150 import statements from your application and there's no consequence because you never actually use the thing that you imported. So that's really helpful. And also like good tools, like good code analysis tools can also help you find even like variables that you've defined and never used, or like dead code, or just patterns that you've used which are probably not a good idea. Like Python is weakly typed, so
right.
You can just stick properties on anything. It doesn't really matter. But like a linter can also tell you, oh, you've referred to this property on this thing, but I don't think that actually exists. So actually, linters often help you find silly bugs like that, where actually it's just going to cause a runtime error and say you tried to access this property, but it doesn't exist on that variable. And then you've kind of got like code formatters as well. And there's a whole range of different ones out there. I'm pretty keen on Black because it's not configurable. So it's not a...
yeah.
Like I like to just run it and then we're like done with it.
Yeah. That sort of forget it kind of thing is kind of nice. And it avoids the conversation about the formatting. It's like, well, that's the format, and I can kind of see how in organizations, how that can kind of devolve into what should be like a code review turns into like a formatting review, which is not really what it's intended for.
Yeah, definitely.
So I have a couple like regular questions to ask, kind of weekly questions. I kind of have a new one. Do you have like any tricks or techniques or tips that kind of less known, not necessarily hidden, but techniques that you use in Python?
Yeah, sure. So one of my favorites actually, which I think I either refer to in the refactoring application, but actually this trick I used a lot more in a project that I work on called Wiley, which is a code complexity analysis tool. So it kind of like looks at your code and says, oh, that module is like super unmaintainable because it's got like tons of nested loops and it's really complicated. So it kind of tells you that stuff as like a commit hook. So you can see if you've made a change, if it's made the code less maintainable, it'll give you a warning. But in the code itself, I kind of built this data structure, and I was basically like creating a what we call like a mapping type. So a mapping type would be like a dictionary, for example, is a mapping type in Python.
Sure.
So you would use the variable name and then square brackets and then the key inside the square brackets. So sometimes you end up creating mapping types which are not dictionaries, but you've kind of made a class which kind of behaves a bit like a dictionary. Like you load some data from somewhere, and then you can have like a function on it to say get, I don't know, like get user or get person or get product or something. But actually, then in the code, you're calling this method all over the place. And Python has got this thing called the object model, and container types have got a like a special magic method that you can implement on the class called dunder contains and dunder get item. And I really like those in the object model, because then you can, if you use dunder contains and you had a variable called products, for example, and you had, and you wanted to get a product by ID, you could do dunder get item. And then you can just do product square brackets and then the ID, and it would just give you back the product, rather than having a special function to do that and having to remember what the function was. And you just find that if you use the object model more in your custom classes, then you can refactor your Python code to be a lot simpler and easier to read, which down the line is great.
Yeah, that sounds awesome. I think that the Wiley project is something that Kyle Stratus mentioned in our talk last week, and he mentioned that he uses it as a good project to study for the way the code is organized. I was asking him to maybe give examples of projects that could be good for people to read through. When we're working on that project?
Yeah, I was working on it last year mostly, but it's open source. People can use it now. You just pip install Wiley and follow the guide, really. So yeah, I'm still kind of maintaining it and adding a few features and stuff like that, but it uses your Git history.
Okay.
So it will analyze your code complexity through the Git history, and it will give you a trend. Because if you run code analysis tools or code complexity tools, it will say your code complexity is 500, and you're like, okay, great. But this is a bit more granular. It just says this module or this part of the code got more complex over the last year, and it gives you a graph and stuff.
Oh, cool.
You can see per commit where it got out of control. So often it just kind of tells you which parts of your application you probably want to refactor, because they're going to become these big ugly classes or functions that just do 1,000 things, and it's got all these nested for loops and all this if branching, and only it takes you a good hour to sit down and figure out what on earth it's doing.
Sure.
So yeah, it helps you identify that stuff basically.
So what's something that you're excited about in the world of Python? Again, it could be an event or a package or coding tool or hardware.
Because I've been researching Python 3.9 a lot for the book. So 3.9 will be coming out later this year. There's a new experimental feature in 3.9 called subinterpreters, which if you've ever used the multiprocessing package in Python, it's a standard library. Multiprocessing is kind of a simple way of starting multiple Pythons. So it'll actually start multiple Python processes, and you can give it a queue of tasks. So if you've got something that's really CPU intensive, Python won't share that task amongst multiple cores or multiple CPUs out of the box. You have to kind of schedule them on different Python processes. And the way to do that at the moment is to use a third-party package to do that, or to use the multiprocessing package. So with multiprocessing, you can define a function that's your worker function. You can define a set of inputs, a queue or something. And then you can say multiprocessing.pool, and you can give it a pool of processes, and it will spawn the Python processes and give them the data and give them the function to run. And then it will get the results and give it all back to you. So it's a really nice way of doing parallel execution of stuff that's really CPU intensive, and it will split that stuff against all the cores in your machine. The big downside with multiprocessing is that it starts a separate Python process, which has quite a big overhead. And if you want to share data between the processes whilst it's running, it's quite tricky to do that. You've kind of got to use the pickle module, which is not super efficient and it's quite slow. So there's a new experimental feature coming in 3.9 called subinterpreters, which is basically a lighter weight version of doing that challenge. So rather than starting a whole separate Python, it creates a separate interpreter, which most people won't be familiar with what that even means. But internally inside Python, your environment sits in a scope called an interpreter. An interpreter has a thread, and it has a lock called the global interpreter lock.
Right.
and it has functions and modules and stuff like that. So like that's your namespace inside Python. And in 3.9, you'll have the ability to kind of like create multiple namespaces, but within the same Python instance. And that then would allow you to use the operating system scheduler to kind of spread that workload across multiple cores. So you can kind of do that already with multiprocessing, but in 3.9, that's like kind of remove the overhead of doing that by about, from what I've tested anyway, about 30%.
Wow.
In terms of both the startup time and the CPU overhead.
It makes the sharing of the data easier too. It avoids the pickle problem you're talking about.
Yeah, it does. So you can use shared memory spaces. And if it's like a simple type that you want to share data, so like an int or a string or something, like you don't need to use pickle. You can just share it in shared memory.
Okay. So the circumstances where you'd use the pickle would be like you're doing like big data frames or something like that.
Yeah, if you wanted to share something a bit more complicated, like a data frame or something like that.
Okay, cool. That sounds very cool. I think that might be something that Brett Sutkin was talking about. He mentioned the PEP number, but he didn't say that it was actually going to be part of Python 3.9, which that sounds very exciting. So
yeah.
And so the last one is what is something you thought you knew about Python, but it turned out you were wrong about it?
So this is, I guess, the first time I saw Python was in a tool which probably doesn't even exist anymore for making, it was a map editor for Quake and Half-Life, the games.
Oh, there you go. Nice.
So this is probably quite old. And the map editor actually used Python to like do the map rendering or something. I'm not really sure, but like that was the first time I even saw the word Python like using the map editor, and it had the old Python logo. It's like the smiley snake. So that's probably like Python 1 actually. And I thought Python was a scripting tool like Perl or Bash for like doing those types of scripts. So it's only really kind of when I actually got to use Python later on, I was like, oh, you can actually use it for like all this other stuff. I thought it was a scripting tool, and it often got referred to as a scripting language. And lots of places where Python used to be used, like in the Red Hat operating system, for example, like it was used as like the main scripting tool for like Red Hat packaging and stuff. So yeah, that's what I thought it did.
Well, I really want to thank you for coming on and talking to me, Anthony.
Yeah, thanks. It's been great to have a chat, and hopefully people have a bit more encouraged to have a start with testing or, kind of improve some of their testing and their applications.
Yeah, that's great. Thanks again.
All right, thanks. Bye.
I want to thank Anthony Shaw for being my guest this week. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.